Today we're going to speak about web services, giving a very quick overview of what they are and a quick overview of the two major types of web service. First of all, what is a web service? Well, it's a reusable piece of software that is addressed using a URL. That means it can be accessed over the internet. It's also self-contained, and by that we mean it describes its capabilities, it publishes its interface, and it implements the functionality so that it contains everything we need to know about it, and it provides the functionality. The great thing about web services is that they are very loosely coupled. They're standalone bits of software that other applications can tap into to achieve the desired effect. And because they are loosely coupled, it means that any kind of application, as long as it has a capability of connecting across the internet, can make use of it. It doesn't matter whether it's of the same programming language or different, if it's of the same application type or very different. And so this is going to throw up, or has thrown up over the last few years, a new architectural paradigm. These web services expose their capabilities to other applications using standard interfaces and protocols. And that's why they can be used by non-homogeneous systems. Because an application is using a web service but not integrating with it, it means that the application remains independent of the web service. One of the things that we need to think about is what kinds of web service there are and whether they are useful for our application, and then we'll think about a few other things a little bit later on. Now here are some examples: currency converters, stock quotes, market data, global weather, and so on. If we take a look at this website, there is a list of services which are fairly good examples of the kind of things that can be done. Let's take a look at global weather as an example. We can see its description and we can see the interface that it exposes. Let's take a look at getting cities by country, for example. Let's put in United Kingdom and submit. And what we get is a rather fearsome looking table that actually is an XML document. And we can find in there a city, Birmingham/airport in the United Kingdom, and we could go and ask for the weather conditions at that location. And that's a fairly good illustration of the kinds of things that web services do for us. They expose an interface, we use a particular method in that interface, and we get a response, very often an XML document. And so this can change the architecture of our applications. Traditionally, when we needed capability A and capability B, and then using capability A and B, we would encapsulate all of those in the same application. Now, with a web services oriented application, we can make use of these capabilities, A and B, that have been published elsewhere. And making use of the network, we can connect with those and make use of them. Now our application becomes very much more a case of using published services and then presenting the results. So it changes the focus of our applications. But there is a bit of a downside, and we'll talk a little bit more about that in a moment. But think about this. Web services are being developed and managed by other companies. And if we start making use of those web services, that puts some kind of dependency now from our application to their services. We are now beginning to rely on other companies continuing to develop and manage those services. The standard protocol that is used is called SOAP, which is an XML-based protocol. The slight problem with that is because it's XML, it's very verbose. There's a lot of information that goes around the data. And so if you want to send one small number, maybe it's the string 2-4, just 2 characters, there's a lot of XML element definition that goes on around that, which makes it very verbose. So some of the benefits of using web services include reducing the development time and costs. Because other companies have developed these services, we don't have to. We just need to make use of them. Presumably, these other companies will be domain experts. And that means that if I want to do something like that, I no longer have to be an expert. I can make use of their expertise through their published web services. It introduces a very nice separation of concerns because it gives all the responsibility and all the management of global weather or stock markets or whatever it might be, gives all of that responsibility to the company that provides the web service, the responsibility for processing the data and presenting that data, that stays within my application that I'm developing. We can also compose new web services from existing web services. For example, there might be a web service for booking taxis. There might be a web service for booking flights. And we could invent our own web service that taps into both of those web services, and all of a sudden we've got our own web service that will book both taxis and flights. And I can set up a new company based on that. You want a flight? Here's a taxi that will take you to that flight without the user having to make two separate bookings. And so that could very well give opportunity for a lot of growth in the industry, because we're now making use of these web services that are published by other people. But some of the downsides include loss of control over the capabilities that are provided by the web services. If I'm using somebody else's web service, I'm completely at their mercy. If they switch off the web service, I've no longer got that functionality available in my application. And I have to consider what will be the effect on my application if a web service is lost. And some of the things that might be considered as we start to choose which web services to use might include: who should I partner with? There might be 2 or 3 offerings in terms of web services in a particular area. Who would be the best partner? How would I know that they're a good partner before I actually commit to using their service? What track record do they have? What service levels do they guarantee? So in considering all of those things, we need to know a little bit about the basic components. There's a web service producer. This is the entity that will write and publish the web service. There's the web service consumer. Those are the applications that make use of the web services. My application would be a web service consumer. There's the web services description language, which is an XML-based language that is used to describe a web service. There's SOAP, which is the Service-Oriented Access Protocol, also XML-based. And then we've got the UDDI, the Universal Description, Discovery and Integration, which is also XML-based and is a registry of web services. So a web service producer will publish in the UDDI details about the web service that they've just developed. And a web service consumer can discover from the UDDI what web services are available. This could become automated. When the consumer has made a choice of web service, then the consumer will send a request using SOAP to the web service and get a reply also using SOAP, providing the data that has been asked for. So those are the basic components and the basic architecture. Now, when we're publishing information about a web service, some of the information will include, for example, the target namespace, the types and the names of elements that are to be used. The various elements can be operations, inputs, outputs, and faults. We'll also define the interface in terms of the operations that are performed and that are offered, and these will be simple interactions between client and service. There's also other information, including, for example, how we can bind to these operations, what format to use, what transmission protocol, and so on. HTTP is a very popular protocol because most firewalls allow messages using HTTP to pass through without any problem. Now, the thing about a SOAP request is that it is verbose. It's XML based, which makes it verbose anyway. It has an envelope which declares that the document uses SOAP. It's got a header, it's got a body, it's got details about faults. All of that is a lot of information. And that information is really quite difficult to write manually. So usually these SOAP messages are generated automatically. WSDL and SOAP are industry standards. We can make use of them in any application, and that's one of the things that makes the non-homogeneity possible. In Java EE, when we're making use of web services, we'll make use of a package called JAX-WS. This is an API that enables the processing of requests to and from web services. And amongst the things that will be done is that we will write Java classes that implement the interface methods, and we can then publish that as a web service. We can write clients that will interact with those web services, And the very great thing about this, the lovely thing about this, is that there will be no need to write code that deals with SOAP messages, because that's all handled by the JAX WS API. And that's a great advantage because, as I said a few moments ago, those messages are extremely verbose. Now, if we're going to use a web service, first of all, we need to know where it is. So we'll need the URL of the WSDL file, and then we can create an application that uses it. It might be a client application, or it might be a web service client. It could be any kind of program. In this module, we'll be using NetBeans to do that kind of thing. One of the things that we'll need to do is to connect with that web service and then call the methods within the service. We get a response. That response is full of data. We then process and display the results. Now, there's an example that you can download from Blackboard that is a Java client. It's just an ordinary desktop-based application with JFrames and JPanels and so on. Of the 224 lines of code, only 35 of those are anything to do with the weather. The rest of it is all about presentation of information. And that's indicative of the benefits of making use of web services. It reduces the amount of work that we have to do as developers. If I'd wanted to write a desktop application that got hold of weather information and I wasn't making use of a web service, just think of all the activity that I would have to go through on a daily basis to gather all the weather readings from all around the world, gather those into some kind of repository, and then make that information available to my application. A huge amount of work. Somebody else is doing that for me. So all I've got to do is to tap into their web service and obtain the data that they've already gathered. If you run that application, what you would hope to see is something a bit like this, where we can type in the country name in the top left corner. That will, as I showed you just now in the web browser, will contact the web service and download all the cities in that country. And then click on one of those cities, and in the right-hand panel, you'll get the result of the application contacting the web service again, asking for the weather report for that city. I said this is what you would hope for, because since I wrote that application, that web service has changed. And this really nicely illustrates the risk that a developer takes when using a web service. As I illustrated just now, using the web browser, we can still get hold of a list of cities for a given country. But then when you ask for the weather report, that bit doesn't work anymore. And that kind of makes this particular application rather silly looking. The whole point of that application has just been defeated because the web service no longer does what it claims it's going to do. Another type of web service that is available and has been on the scene for a few years now, but is newer than the original web services, are known as RESTful Web Services. What we've been looking at up until now are the so-called big web services, because these make use of SOAP and WSDL, XML-based and verbose. The messages are huge, even for a very small bit of data. The RESTful format, and REST stands for Representational State Transfer, doesn't require WSDL or SOAP at all. But it does require that both the consumer and the producer agree on the interface, data and format that are to be used. One of the advantages of RESTful format is that the message size is very much smaller. And this will make it much more useful for mobile devices because there's a lot less processing to do and therefore less power consumption. There are 4 basic design principles for RESTful web services. Use HTTP methods explicitly. So these are the HTTP requests: get, post, put and delete. Be stateless, so that the web service does not have to keep any state at all between requests from a given client. One of the other principles is that we expose URIs as directory structures, and we'll talk a little bit more about that in a few moments, and be able to transfer XML or JSON or both. Now, the nice thing about transferring JSON is that we have a definition essentially of objects as a string. So our objects are converted to strings and passed as a string, which is very easy to do in the HTTP format. Those strings can be reconstituted as objects at the other end of the connection. Now, using the HTTP methods explicitly means that we're going to do things like retrieve a resource. In other words, ask for some data using a GET request. If we want to create a resource on the server, then we would use a POST request. If we want to change the state of a resource, which would include, of course, updating it, then we would use a PUT request. And if we want to instruct the removal or deletion of a resource, then we would use an HTTP delete request. So those are the meanings of the standard HTTP methods in terms of a RESTful web service. Now, being stateless, it means that servers can be clustered and we can have load balancing between those servers, and that means that the request from a client will go to a server and the next request from the same client could very well go to a different server. And that's one of the reasons why being stateless is a good idea. Because if you store state on one server, then you really ought to have the next request from the same client go to the same server. And that can be a bit of a problem when it comes to load balancing. It also means that requests can be forwarded from one server to another to increase the responsiveness of the web services. And because there is no state, it doesn't matter. But it does mean then that clients must send complete independent requests. In other words, each request from the client has been made on the assumption that the server knows absolutely nothing about the client or any of its previous requests. And so the HTTP request headers and body hold all the information that is necessary for the server-side components, the web services, to do the job that has been requested. The effects of this then is that it can improve the performance of the web services. It will simplify the design and implementation of the server-side components, but the absence of state on the server means that the client's got to do a little bit more in terms of maintaining state and transmitting that state so that the web service can do its job. Exposing URIs as a directory structure is a good thing in as much as it can make the URIs intuitive to the point where they are very easy to guess. For example, if you're requesting from a transaction log an event or a series of events that occurred on a particular date, then the URI would be, well, first of all, it would be a GET request because you're asking for information. And then in that URI, you would include the date as a series of folder structures. So you'd have the year / month / day. And that appears as if it were asking for a request in a folder structure. In fact, what you're doing is passing parameter information as part of that URI. These RESTful web services can transfer XML, JSON, or both. And the way that we would identify that is by identifying the MIME type of that request. Part of the HTTP protocol is to have in the header an element called accept, and that defines the type of data that can be accepted. For example, if we wanted JSON, we would define the accept header to be equal to content type application / JSON. If it's XML, application / XML. Now, Android apps process JSON objects, in part because it's a very succinct way of packaging an object and sending it. Now, here's an example of a web service that has been generated in NetBeans. It's based on a table in a database. So this is one way in which we can generate a web service. Not necessarily the best way, but it's one way. Having defined the table in the database, we can then in NetBeans right-click on the project, select New, Web Services, and RESTful Web Services from Database. That will put up a dialog box in which we can select the table that we want, or tables that we want to base the web service or services on. And then when we say OK, NetBeans will generate quite a few things. And you can see on the right-hand side of the screen the kinds of things that are generated. For example, in the source packages, there's a package called contact, which contains the entity contact.java. Below that, another package, which is a package of web services. It contains an abstract facade, which defines the methods that can be used. It also defines a configuration file and the REST web service itself. Now, the abstract facade class will define methods create, edit, remove, find all, find range, and count. We can edit this and put in more if we want to, but those are the general things that are generated. We will find in the RESTful web service methods to respond to the 4 HTTP requests. And the configuration class will register that web service as a resource in the server. And that will make it available for requests from clients. One of the nice things about NetBeans is that we can then test our web services without having to write an entire application to test them. So we can right-click on the project name and select Test RESTful Web Services from the pop-up menu, and that will automatically generate a whole load of test classes, which will then deploy to the server, and a web browser opens and it will look a little bit like this. You can see on the left that the web service is listed with its operations, and we can, on the right hand side, put in some information. So for example, we might want to choose the Get JSON option and then click on Test. And at the bottom, we'll see the status, which is the return code from the server. 200 means it's okay. And then just at the bottom of that, you can see in the response table the data that has come back as a JSON string. So that's a very easy way of testing that web service to make sure it's doing what we expect it to do. In the method to test, we could also choose post or put if such capability has been published in the web service, and even delete. But a thing to note here, with delete in this particular test environment, the delete will not be sent as a delete request. It will be sent as a GET request. So the deletion will not actually happen, but it does give you the capability of seeing that the delete is available and seeing the request has been sent. In your applications, in your clients, you will need to make sure that you send it as a delete request when you want the delete actually to happen. A couple of closing thoughts. Going back to the idea of quality of service, these are some things that we might want to use to judge how good a web service is when we want to make use of it in our applications, or conversely, how good our web service is when we are publishing it. This is a means of predicting and managing resources that are important to the runtime performance of an application. We might want to consider quality of service metrics such as availability, which is how often that service is available for consumption. How accessible is this? How capable is the service of servicing a client's request? So that it might be available, but it might be busy doing other things. How long does it take to respond to requests from clients? This is a question about performance and efficiency. Does it comply with stated standards? How secure is it? Now, this is becoming more and more of an issue in today's world. How secure is it for an application to interact with that service? Is the service trustworthy? Is it going to do what it says? Or is it going to capture information that we might not want it to capture? And what's it going to do with that data that it has captured? How energy efficient is this service, especially for mobile applications? And this really is a function of the number of bits that are transmitted. Services that are using SOAP will not be as energy efficient for a mobile app as services that are using JSON objects. And then reliability. How often does the service fail to maintain its overall quality of service? Or put the other way around, how often does it succeed in maintaining its overall quality of service? Obviously, the higher the number, the more reliable it is. And these are things that we might want to publish about our own web services when we're trying to invite potential customers, potential clients to use our services.